In this video, we'll be learning how to graph child graphs using what we know about transformations. So throughout your time in Algebra 1, you've learned about three main types of graphs. We have the linear, absolute value, and quadratic graphs. And what we learned about these is that the values of a, h, and k, regardless of which graph they are transforming, they transform the graphs in the same way. So we know that a is our vertical stretch, vertical shrink, and vertical flip. We know that h are our horizontal translations, and they work the opposite of what we expect. And then we have k, which are our vertical translations, and they move the graph up and down. So what we're going to do is we're going to use our knowledge of transformations and those values of a, h, and k in order to transform a parent graph into its child graph. And these are the 4 steps that we're going to take as we do this. So the first thing we're going to do is we're going to discuss what h and k do, because we know all parent graphs are centered around this 0, 0 point here. But we know that the h and k values move the graph left and right. So what we're going to do is we're going to use our values of h and k to determine where that middle point of the graph is going to be. And then what we're going to do is we're going to find points around that middle point. So here to start, I notice that my h value here is 3. So this tells me that I'm going to do the opposite of positive 3. So I'm going to move in the negative direction along the x-axis, which means I am going left 3 units. And then here's my k value, and I know my k value moves up and down as expected, so because it's negative 4, it's going to move down 4. So what I'm going to do is I'm going to take my h and k value, and I'm going to move the middle of the graph from 0, 0, left 3, 1, 2, 3, and down 4, 1, 2, 3, 4. So this point right here is the middle of my graph. That is where, if I have a quadratic graph, it's going to be my vertex. Same with the absolute value graph and the linear graph, it's just the middle of that line. So we've applied our h and k values, and we found the middle of our graph and plotted it. And now what we're going to do, because all we're doing here is we're just making a sketch. We don't need a super full-blown large graph with 5 to 10 points. We just need a brief sketch of this graph. So I'm going to find one point on each side of that middle point. And typically what I do is I go one x value to the right, so here I see negative 2, and one x value to the left, which is negative 4. So I'm going to calculate what the y value is when x is negative 2 and when x is negative 4. So we're going to start off here with x is equal to negative 2. And I am just going to substitute that right on into my equation. So here, if I substitute in negative 2, I'm going to write y equals, remember f of x is just a fancy way of saying y. So I'm going to write y equals negative 2 plus 3, quantity squared, minus 4. Well, I know that order of operations says I have to do parentheses first. So here I have negative 2 plus 3 is 1 squared minus 4. Which then I do my exponent. 1 squared is just 1 minus 4, which is negative 3. So I'm going to move over. I know that my coordinate is x is negative 2, y is negative 3. So I can plot that point right here. So I've taken care of one of my x values, the one to the right of my vertex point, and I have found when x is equal to negative 2. Now I'm going to do when x is equal to negative 4. I'm going to repeat that same process. So here, take x is equal to negative 4. So I have y equals, in parentheses, negative 4 plus 3 quantity squared minus 4. I then know I do parentheses first, so here I have negative 1 squared minus 4. Negative 1 squared is 1, so that's 1 minus 4, which is negative 3. So here my coordinate is x is negative 4 and y is negative 3. So I go over to my graph and I plot x is negative 4, y is negative 3. So I have found a point on each side. Now, you don't have to do the points directly next to it. You can do points that are 2 out. It's completely up to you. The important thing is that you get a point on each side of your graph. And then from here, we're going to draw a sketch of our graph using the type that we know this graph is. Because I see a squared here, I know that this graph is a quadratic graph, which means it's going to have that U shape. So it won't be pointed or have lines in any way. It's going to have a curve to it. So I'm going to connect these dots, but I'm going to make sure I connect them in a U-type shape to create that quadratic graph. So that is just a basic sketch of my quadratic graph. Notice that I found all 3 points, and then I extended it up and through the coordinate plane. Now my last thing here is I'm going to find my domain and my range. My domain, I know this graph is going forever to the left and forever to the right, so I know my domain is all real numbers. And then my range, if I look closely here, what I notice about my range is that the lowest point here is -4, and then my graph goes up. So my range are all of the y values that are greater than or equal to -4. So let's go through the same process with the second example. Here, if I look here, I don't see an absolute value or a squared, so I know that this function shape is going to be a linear graph. So that's what I'm expecting to see at the very, very end. Now I'm going to start by identifying my h and my k values. What I notice here is that there's no parentheses that contain x. Typically, we would have something like, x minus 2 and then have the -7 out here. Since we don't have anything there with x, since we don't have anything there, that just means that our h value is equal to 0. And what that means is that there's no horizontal change here. We're not moving the graph left or right. What we do have, however, because it's outside of parentheses of x, would be a k value that's equal to -7. So this means that our middle point is going to move down 7 units. So we're going to start at 0, 0 and move down 7 units to find that middle point of our graph, which is going to be at x is 0, y is 7. And then what we're going to do is we're going to find a point on both sides of that. So because x is equal to 0, I'm going to move and do x is equal to a +1, and then I'm going to do x is equal to a -1, because that's going to get a point on each side. So here I take y equals 5 times 1, and then I have the -7. I do the multiplication first, so I have 5 minus 7, which equals -2. So my coordinate is x is equal to 1, y is -2. So I'll go x is 1, y is -2. Then from here, if I repeat that same process with x equals -1, I have y equals 5 times -1 minus 7. 5 times -1 is -5 minus 7, which gives me -12, which actually goes off my graph, but I can estimate a little bit and do x is -1, y is -12. Go down an extra 1, 2 spaces, and it's probably about there. So what I need to do now that I have 3 points, one on each side of my middle point, is I need to connect the dots of my graph. And I know this is linear, so it's going to be a straight line going in whatever direction those 3 points take it. So here I connect my points and I have a straight line. Now, because this graph is going forever to the left and forever to the right, I know that my domain is all real numbers. And then because this graph is going forever up and forever down, the range is also all real numbers. So let's do one more example with a different graph type. So here, if we take a look, we see that we have the absolute value symbols. So this is going to be an absolute value graph type. And we expect to see a V shape. So it basically is 2 lines meeting at a point. So 2 rays meeting at a point. So we're going to start by finding our h and k values. And what I notice here is that I have a value inside of here with x, and it's -1. So because it's negative, we're going to go the opposite because this is our h value here. And our h value here is telling us that we are moving 1 to the right, which is the positive direction. So we're going to move 1 unit to the right. Then, because there's no k value here, there's nothing being added on the outside of that absolute value symbol, k is really equal to 0. And what that's telling us is our graph isn't moving up or down. It is staying right where it is after it's moved right 1 unit. So our middle point here is going to be x is 1 because we're moving 1 to the right, and y is 0 because we're not moving up or down. So there is our middle point. Now we're going to find a point on each side of that, and because we have x is equal to 1, we're going to do x is equal to 0 on the left, and then we're going to do x is equal to 2 on the right, because that's 1 point on each side. So let's try to evaluate this. So we have y equals -3 absolute value of 0 minus 1. So what we need to remember is that absolute value symbols work like parentheses. So we need to do that first. So we have -3, and then inside we have 0 minus 1, which is -1. Now, what's tricky about absolute value is you really have to think about the evaluation process here. Absolute value is not just spitting out the number inside. The absolute value finds the distance from 0 of that number. So if we evaluate the absolute value of -1, the answer is +1 because that number is 1 unit away from 0. So here we have -3 times a +1, which equals -3. So our coordinate here is x is 0, y is -3. Now if we repeat this process with x is equal to 2, we're going to do the same thing but with 2 instead of 0. So we have -3, absolute value, 2 minus 1. So -3, we do what's inside the absolute value first, which is 2 minus 1, which is just a +1. Then from here, we have to evaluate the absolute value of 1. Remember, that's finding distance from 0. So the absolute value of 1 is 1. So the absolute value of 1 and -1 is that same value of 1 because it is distance from 0. So we have -3 times 1, which is -3. So our second coordinate here is x is 2, y is -3. Now, we know this is a V shape, so we're going to draw this like a V through our points. And then now that we have a fully complete graph, we need to find our domain and our range. Domain is going to be all real numbers because this graph is going forever to the left and forever to the right. And then our range, because the highest point is 0, and then the graph is going down, is going to be y is less than or equal to 0, because the highest point is 0, and then we need all of the y values that are below that.